Hello everybody. Today we're going to work on drawing three-dimensional cyclohexane rings on two-dimensional paper. First I'm going to start by drawing the two-dimensional cyclohexane ring you see here. All this is a hexagon, and if it has substituents on it we can tell if they are trans or cis by drawing either a dashed wedge, which means that the substituent as we look at it is going into the paper, or a solid wedge, which means that as we look at this molecule, the substituent's coming away from us. Now, if we look at this three-dimensional model of cyclohexane, we can see that for this to be trans, we can either have two axial substituents or two equatorial substituents. In this particular example, because cyclohexane rings undergo a lot of free rotation, they actually interchange between both being axial and both being equatorial in the trans isomer. But of course they spend more time equatorial because it's more energetically favored for them to be there, where they're less hindered and bumping into things when they're axial. But that's beyond the scope of this video. Let's just discuss how to draw these three-dimensional rings. Now what we want to start out with here is just drawing a simple, slightly diagonal line going down like this. Next we want a line, if we go from this corner, going down slightly, that is the same length but parallel to the first line. My second line looks kind of curvy, but let's not be artists here, let's be scientists. Next, at about 120 degrees from this, we're going to want to draw another line. And then, on this one, in kind of a reflective manner, we're going to draw a line that's also 120 degrees. But it's going to be parallel to this line. So if our first angle is a little bit off, this one's going to be off too. But it's no worry because it all works out in the end. Next, we're going to connect this corner to this corner, and this corner to this corner. And if we were very careful as we drew this, these two final lines should also be parallel to each other. Bam! So far so good. The next trick is drawing the substituents on this ring. Now, 1, 2, 1, 2, 1, 2. You can see this ring is a parallelogram, and that is going to help us draw our substituents. First, I'm going to draw an axial coming up, as if this is a spoon scooping up cereal that goes straight up. The axial substituents on each one of these corners go straight up, or in this case straight down, depending on which direction this little scoop thing is facing. So I always think of a spoon lifting up a spoonful of cereal to my mouth or something whenever I see this. So in case you want to learn how to draw cyclohexane rings properly, just think of breakfast. Next we have these two intermediate corners. To draw the axial substituents on them, we just look at whatever direction these corners are pointing in this case they're both pointing up, and then we draw the axial substituent pointing up also. And it's going to be parallel to both of those axial ones we already drawn. So parallel, parallel. So far so good. These ones are both pointing down, so their substituents are going to be pointing down also, and they're also going to be parallel to everything else. Again, parallelogram. The parallel lines here are a big part of how we draw this thing neatly. Next we want to have the equatorial substituents. And to do that, we look at the carbon in the corner that we're facing, right? And then we count 2 bonds over. It doesn't matter which direction we count from because each one of these bonds are going to be parallel. So this one needing to be parallel to both of them is going to be parallel to either one and at the same time both. So let's count 2 over in whatever direction we decide. 1, 2, or 1, 2. Fine. I see these lines going in a certain direction. I want to make this parallel to them. Okay, there we have it. Now we have our first equatorial one, and this is actually pretty sloppy looking because of the way this was drawn, but this one is a neater example, I had more time to do, so let's just keep it moving. Next, the equatorial substituent here. Count 2 bonds over, 1, 2, this direction, 1, 2. These are both parallel, this is going to be parallel to them. Bam. We have our second substituent. We do the same thing here, equatorial, 1, 2, 1, 2. This is the direction they face. This is the direction that faces. So far so good, we're done. Over here, 1, 2, 1, 2. Those lines are parallel, this is parallel to them. And keep repeating until we have everything filled up. 1, 2, 2, 2, 2. and bam. Now, I don't like how this turned out over here because it kind of looks like they're sticking straight out from each other, but this is not 180 degrees. This is just a sloppy example of a drawing right there. Look over here for a neater example. So when you draw it, you want to start out with the first two lines parallel, then draw about 120 degrees lines coming out of both of those, connect this corner to that, and then this corner to that. These lines will also be parallel. Draw the axials coming straight up from the little spoon scoops that it makes. Then draw the rest of the axials parallel to those first two axials, and make sure they're pointing in the same direction as the corner you're drawing them on. Then with the equatorials, you just count 2 bonds over and make them stick out parallel to those bonds that are 2 bonds over from it. And before you know it, after a whole lot of practice, you can end up drawing this thing nice and neatly on the first try, and you'll be set. So I hope that my tutorial has helped you drawing your cyclohexane rings, and feel free to ask more questions, and I will post a video response as soon as possible. Have a nice day.